Today we are going to look at systems of equations. We are going to solve them algebraically. We are going to look at linear quadratic systems, so a parabola and a line, and where they intersect is going to be the solutions. If we look at the first picture, there are two solutions to this systems of equations. The first solution is at -3, 0, and the other one is at 5, 8, where the line and the parabola intersect. If we look at the second graphical example, there's only one solution at the point 2, -6, because the line only hits the parabola at one point. And finally, at the third example, the parabola and the line will never intersect, so there are no solutions. When we are to solve it algebraically, these are the steps that we should follow. We should get the linear equation in y equals mx plus b form. Replace the y in the quadratic equation for the linear. Set the equation equal to 0. Factor to solve for x, and then plug back in to find the corresponding y values. We have two examples to do together today. For the first example, I need to get that y equals, so I'll add an x, and it'll become y equals x plus 1. From there, I can do step 2, which is replace the y in my quadratic for the linear. So it'll be x plus 1 equals negative x squared plus 6x minus 3. From there, we set it equal to 0. So I'm going to add x squared, subtract 6x, and add 3 to both sides. The reason I'm moving the right-hand side to the left-hand side is so that way my x squared will be positive. When I move it over to the left-hand side, I get an x squared minus 5x plus 4 equals 0. From here, I factor, which is step 4. X squared minus 5x plus 4 factors to x minus 4, x minus 1. Set your factors equal to 0. So you get x equals 4, and you get x equals 1. On a Regents exam, this is worth 6 points. Right now, you have 5 of them. To get the 6th point, what you have to do is you plug your x's back into one of the original problems to solve for y. So I'm going to plug into the linear. It's usually easier to do that. So plugging my 4 in, it would be y minus 4 equals 1. To solve for y, add 4, so y equals 5. So my one solution is 4, 5. And do the same thing for the 1. When I plug a 1 into the linear, I get y minus 1 equals 1. Solve for y. By adding 1, you get y equals 2. So your solution here is 1, 2. And that's it for that problem. Let's look at the next one. On the next one, the first problem is already a y equals, so we're going to leave it. Now we are going to substitute the linear into the quadratic. So it's 11x plus 6 is equal to 2x squared plus 3x plus 4. Now I'm going to move the left-hand side to the right. That way my x squared will stay positive. And we will end up getting 2x squared minus 8x minus 2 equals 0. You might see a GCF of 2, so when you take the 2 out, you get x squared minus 4x minus 1 equals 0. This does not factor. So when it doesn't factor, we have to use the quadratic formula. Remember, quadratic formula is x equals negative b, so 4, plus or minus the square root of b squared, 16, minus 4a, which is 1, c, which is negative 1, all over 2 times 1. Underneath that radical, you get 20. When I simplify, I get 4 plus or minus 2 radical 5 over 2. I do notice that a 2 goes into the 4 and the 2's. So I will be left with x equals 2 plus or minus radical 5. So those are your x values. To find the y's, you plug back into one of the originals. And again, I'm going to plug into the linear. It's a little bit easier. Let me move this over a little bit here if I can. Okay, I guess I'm going to go down here. So When I do 2 plus radical 5, I'm going to plug it into the linear, which was 11x plus 6. So 2 plus radical 5 goes in the x spot, plus 6. Distribute the 11, you'll get 22 plus 11 radical 5 plus 6. Combine like terms, 28 plus 11 radical 5. Same idea for the 2 minus radical 5. You'll get a similar answer here. It'll be y equals 11 times 2 minus radical 5 plus 6. Y equals, distribute the 11, 22 minus 11 radical 5 plus 6. Combine like terms, 22 plus 6 is 28 minus 11 radical 5. Sorry for having to squeeze it in there. So those are my solutions there. At this point, what I would like you to do is to try the do now problem at the bottom.